Stretch it out. Say hello. Get ready for more Bardic lore. Okay, good evening everyone to another episode of Dan Does Data. Tonight we're going to continue looking at our Bardic lore text generation model. You might recall last week, I built a quick series of models to slowly build up a more complex model. So you might see right here, we've got a model where we're learning one character at a time. So we put in one character plus a bunch of history of previous characters. Goes through a single layer, a single long short-term memory layer, and then just tries to predict whatever the next character should be. Very simple thing. We just set up the code to run this. I didn't actually run anything through it because, well, I didn't want to just do this with my basic set with the Shakespeare. I wanted to get some actual simple literature to be able to do this. And last time I didn't have the time to do that. But anyway, you would do this, and then the idea is you grab the weights from that model, you save it off, you build a more complex model by adding some more layers or something, and you kickstart it with the layer, what you've already trained it with. That's the idea anyway. And this process I repeated it 2 or 3 times, something like that. Good gravy. 3 times. So, today I want to start running this a little bit, and we might not be able to run too much of it, but just to verify that it works and does something. And I have some data. I've got 2 things. I've got Dr. Seuss. Someone posted on GitHub, I think, most of the Dr. Seuss stories, such as the Cat in the Hat, all this other stuff. We're going to be losing a lot of the flavor because of the lost punctuation and such. So we have some of that. We got about 6,000 characters or something. And we also have Aesop's Fables translated. So those are all short little blurbs. We have more of that. And then of course we've got the actual full-on Shakespeare, which is actually a very different kind of English than what these are. But I want to sort of train on Dr. Seuss. I want to try a couple things. One, I'd like to convert to Dr. Seuss, train for a little bit on that, because that's kind of simple. And then try it on the Aesop's Fables. What is this mess? Oh my goodness. It's like the end of the book, all the references or something. Oh boy. Oh, this is just an explanation of the fables. Jeez. So I might want to cut that short. Anyway, so we got to process these first. That's always the first part of the problem. And I realize I did not put this on Twitter. You know what? Too late now. Oh well. I didn't tweet out about this. Only the regular viewers. This is for regular viewers only, or people who watch on YouTube later. Anyway, I've got the Dr. Seuss text right here. So we just want to read that in a very similar way to how we read in the Shakespeare text. So, chars, indices, all this good stuff. There we go. Come on down. Up here. There we go. Call this S file for Dr. Seuss. Dr. Seuss. Not too many Seusses. Change that to S. Okay. And we're going to need all these imports. Yeah, there we go. Turn on our auto indent. I'm going to turn on the Python debugger because I will make a mistake at some point. It's going to happen. That'll help us dig ourselves out of that hole. Okay, so read in the text. Simple enough. Right there, boom. UTF-8 can't decode. Really? What is data? This? No, I didn't want all the data. That's curious. Byte 94, position 19991. Is that the end of it? No. 19991. What is that? 148. I probably want it to be like an ASCII. No, I know what I need. Read B. That might be what we're looking for. There we go. Now we have a bytes object. Now if I say raw 19991, still says that. 19992. What's this? /x94. Huh. Oh, no, one more. Huh, that's weird. I don't know what that means. Like, how does it get rendered here? That's a little over 2/3 of the way through. Oh, I bet there's some funky character. In fact. So, already I'm rewarded for taking a look at the data. Let's just go straight to 20,000. So, let's find out what this is. Clause Y, comma, something. Clause Y. Oh, yeah, hey. Doesn't know what that is. Santa Claus Y. Oh, it's like a quotation mark after a comma or something. Is what the problem is. So here's what we're gonna do. Oh, so we read it. We have it. It's just in this. Yeah, it's a bytes object. So if I try to do this, can I do that? I can. Yeah, but I can't do that. Because those are integers. K is a set. But those are all, as far as it's concerned, just integers. I need different encoding, or I need to do something else when I encode, so I don't want to do that. I need open question mark. Writing, yada yada yada. Encoding. Text mode. Coding is not specified. Like, I'll probably just want ASCII, but it's going to yell at me for that too. Always a problem with Python. Or if I say encoding equals ASCII, what happens? Probably still going to complain. Yeah, can't code byte 94. I can delete the character from. Yeah, I can certainly just delete the character from the file, but I like to have a somewhat robust solution. That's one of my coworkers. He was suggesting things like that. Like, just fix up the file, manually do it. Like, no, I want to have a program that I can just run that will do it. And that way I know I'm doing it right. Because inevitably I'm going to screw something up and have to re-download the file and forget about it and I'll have to do that again. Like, doing things again is, that's just the worst when you have the capability to program. There's a way to set what to do in the event of an error, though. I think you can say, like, error equals ignore or something. So, like, you ignore that particular character, which will have the same effect. Let's see if I do that right. Error is an invalid keyword. Erg. Error. Oh boy. Errors. Errors. Plural, of course. Strict. Pass ignore to ignore errors. Ignoring errors can lead to data loss. That's fine. That's exactly what we want. We want to lose data. Let's try that again. Hey, what do you know? Now we have a string. Type of raw. String. Perfect. Length of raw is probably one less than what we had before. If I say raw 19991, yeah, it's something else. 80 to 20 was so smart, and that's a totally different thing. That's interesting. So smart. Interesting. I seem to have lost a few characters. Tell you what, maybe not ASCII, because there might be a handful of things that I don't want to get rid of. Maybe I do. Interesting. There must be some... There can't be any other errors. They just nuke that line or something? Santa Claus, comma, Y in raw. True. Is there a find? Yeah, there we go. Let's try to find this. That's just very strange. 999987. 198. Very odd. Did I have that right before? Oh well. It's mostly there. I'm actually not that terribly concerned about it. Our lowercase is this stuff. Yeah, so this is stuff we're junking. So new lines, spaces. Oh, everything but spaces. Yeah. All this jazz. And it looks like there might be other stuff. Extra. Read all about it. Do I just want this stuff? Everything that's in... Hang on. Everything that's in text, minus the lowercase letters. Lowers plus extra. Oh, yeah, sorry. So I'm allowing some punctuation. Semicolons, there are semicolons. There's lots of colons, too. Sure, we'll keep this stuff. He's got some special quotes in there. There's quotes, various types. I'm allowing one kind of quote, but not both. Because that's how we're doing things, apparently. Alright, let's see if we can make this data now. And strip down. Collect repeated spaces and new lines. Rip them all down. Now what does day look like? Funny things are everywhere. Every day, from here to there, funny things are everywhere. Perfect. There's a list of all our characters, our max length, and our step size, all that jazz. Yeah, well, not that max length, but let's just get rid of that. There we go. Okay. Let's compile the simple model. So this is the simplest possible model we have. And I generate my sentences in time. Let us see how that's actually going to work. Oh yeah, that didn't work at all. List index out of range, really? T, char? What? Oh. Sentences. There are no sentences. Well, isn't that special? Why not? Epochs. There's 5. Num blocks. There's 5. J, B. Those are right. First of everything. Next jars. Those are both empty. What is I? I is 0. Length of data 0 is 1. Alright, something went wrong here. Something went very, very wrong. This is my typical business. How do I normally train here? How did this even work? 0, length of data B. Oh, truncate the data and reshape. Key pieces that I missed, you know? Thought I was grabbing everything. I was not. Well, at least I identified that right away. This goes here. Okay. So right now data is all the actual text, which is obviously not what you want. You want a whole bunch of integers. Or whatever is the case may be. These kind of things. There we go. So we've already compiled the model. That's fine. Model.summary. Just take a look at her. Yeah, there we go. 32,000 parameters. You know, not the end of the universe. And most of that is going from this first layer, the embedding to the LSDM, just because that's the 48 times 64. That's the biggest, the biggest matrix you got to deal with. Okay, now we will convert, use what we've done before. Hopefully this should, nope. Invalid syntax, really? I'm suspicious of that. In line 1, in range epochs. Alright, I think it just didn't quite copy paste correctly. There we go. Alright, see how long this claims is going to take to run. Gotta compile the dang model, that takes forever. Alright, but then we want to take this model and read in some more data, but of a different type. So the charge part doesn't really change. I mean, it might, but... So let me do that here. Call this read in ESOP data, and more data. ESOP. He will be a file. We can read in all the same raw data, whatever. But here's where I want to start changing it. A data. Replace all these with A data. There we go. Perfect. And likewise in here. A data. There we go. And then do that, so you train on one for a while, then you switch and you train on the other for a while. There it goes. Okay, good. This is not going to take forever. That was a serious concern of mine. That it would take approximately forever. This might also slow down my encoding. Validate on 602 samples, yes. Because there's only 6,000 data points in the Dr. Seuss data set. There's like 6,000 characters is all you have to work on. I feel like that cannot be all of the... That can't be all of Dr. Seuss. It's only 6,000 characters. That just doesn't seem right. I thought it was like 6,000 words, maybe. I don't know. That seems awfully suspicious. Proj, Bardic lore. Yeah, there's like 30,000 here. So what's the deal? Yeah, it's saying there's only like 6,000. There's like 6,000 words. But we're not getting all the data here, so something's wrong. Yeah, let me interrupt that. Don't have all the data. What is the problem? Length of data. 5. Right, that's because that's num blocks. Length of raw. 30,000, so that had everything. Let's just list map. Take a look at the length of everything in all our blocks here. Right, I have 5 blocks. That's why it looks like there's list data. I'm an idiot. Everything was fine, and I did not need to freak out. I just, yep, everything was absolutely fine. I gotta do this through 5 data sets. So, I mean, it's not instantaneous, but, also, yeah, I guess I'm looking at a different validation section every time. So that's gonna be a little wacky. That's not nearly as bad as I thought. 30-some%. Accuracy, what's straight up accuracy? 30, 35. Do we have any regularization here? That might be something to introduce. Yeah, here we go. But it's not called like W regularizer anymore. Regularizer. Equals like L2 0.001 or something. Just a little gentle regularization. From chars.layers.regularizers. Import L2. So it wants to go through each block 5 times. I believe that's correct. And then it'll save off whatever information that it has. And we're getting up to accuracy like 40%, but no. Different sections, it has different abilities. If we could get to like 50, I would say that I would be happy with that. But half the time, yeah, you can guess the next letter correctly out of a whole bunch of possibilities. That's pretty good. Yes, this is my Seuss data. Alright, so that's almost done. Not the most exciting thing. I realized I didn't add any, I should have added some more print statements to this so I know where it's at. Oh jeez, not what I wanted. I guess I've got this progress bar. That's what I've got. But I got multiple progress bars. I don't know which is which now. 11 iterations per second. 11 seconds per iteration. That's the single, getting through one epic. So I'm going to go bop, 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 bop. And then we'll get through the next, 10 seconds for 1/5 of the data. So to get through all the data, so I should change this to 1 block actually. That would make my life a lot easier. Where do I screw around with it? Ah, that's why that has to be there. Hang on. That can stay like that. Yeah, this should come up above the data. There we go. Right, because I just want to change this to 1 block, because this doesn't need a ton of data. This doesn't need a ton of splitting up, because it's just not that big anyway. Whereas some of these other guys, they are kind of big. Where are we actually at these days? Validation accuracy has dropped significantly on that particular set. Some of these others, 34, 34, 35. Has it just recently taken a crash? 35, 40, 35. No, it's all over the place. It's really all over the place. So if that's 5 times 5, in theory that's like 25. That's like 5 minutes for this whole thing to finish. Which maybe that's fine, maybe that's not, we don't know. We're just building garbage model here for a second. You know what? I feel like I should be happy. Bardic. And I should see. Alright. So it should be about every minute it spits out a new file. Oh, it's gone through 4, and that was 5. Okay. Just finished. Perfect. Fantastic, fantastic. I want to see what this model generates right now. My guess is garbage. Just a guess, in fact. I'm going to make my object here, my Bardic lore object. I do have a model ready to go, so I can actually make this. If I say build.step 100, verbose equals true. This should work okay. Nope. But got array with shape 1, 20. That's unfortunate. Ah, I didn't do my max length correctly. Okay, hang on. Let's put this down after we train the model right here. DR. We'll call this DR for Dr. Seuss. Max length equals 40. There we go. Maybe 100. Oh boy. And what do I put in here? Nothing. Answer is nothing. Probably it's garbage, is my guess. It might have like word sizes down. There's a word, a wall. Yeah, that's not so surprising. It's got a couple words in here. I hat. The moog, the cake. It's really good at figuring out how long words are. But it has just not gotten the overall understanding yet. So here's something I'd like to do now that we have this. A model that does something. If you just glance at this, you might think it's text. There are a few words in there. Yes, let's make our A data. Make our ESOP data, which is quite a bit longer. I need to grab my num blocks again. Num blocks equals 5. There we go. Compile this model. So this model just adds one additional LSTM cell. And by adding that cell, the one before that, you have to say, hey, also return the sequences. So you get that. You get to keep that history. It's just a convenience thing, so you don't have to build a super complicated model. All right, so then we grab our old weights. Sorry, these are our new model weights. Look at all the zeros. But we're going to stuff in the pre-existing weights from the model before. All these guys. So those are from the old Dr. Seuss trained model. And if I set weights now, I don't know why I said num blocks 8. That's dumb. Removing that. I want to see what this model just generates straight up. Probably nothing of interest is the question, is the answer. Make one out of model 2. There we go. Because we've got this layer with absolutely no training. So it's just randomly going to spew out garbage. Even though you've started to train this other stuff. Oh wow, that's actually... That looks surprisingly sane. I mean, all right, here's something we can do. Let's remake the model 2 now totally random. And now try to generate some stuff. See if it looks like anything. It might just be that my human brain just sees like, oh yeah, there's lots of nice spaces. That works much better than I would have thought. Wow. Huh. I would not have expected this many spaces. I don't think this model actually rebuilt itself. I am highly suspicious. Highly, highly suspicious. Let me change all these Model 2s to something else. Model 2, Model 2A. Yeah, I think it's still retaining the old model. The old, having already set the weights. I want to see what it does. It should be garbage, right? It's definitely recompiling. What? That's nutty. Like, I wouldn't even expect to see this many spaces. you've got 34 characters. They should be relatively evenly spread. There's something funky going on here. Maybe in when I create the model is what's wrong. Let's review. In this class, the Bardic class, how does it work? Yes, here's the problem. I use model there rather than self.model. This has been wrong for a long time. A long time. I think this is okay though, because this passes in probs. Yeah. There we go. Now that's correct. Jeez. One of these days, man. One of these days. Okay. So, random model 2. Let's see what that looks like. Gotta compile the model, take this a good long time. Yeah, okay. This looks random. There's all kinds of garbage. I like that. That's what I wanted to see. Now, let's get the weights from the previous guy and stuff those in. And let's see if it looks the same. I think it might. But it might be, I don't know, that might be a little better. We'll find out. Yeah, okay, still pretty much just as much. Just about as much garbage. Because even though you're giving it good starter weights, it's got random weights in this layer. So you're sort of just randomizing whatever you threw in, and it's being ignored to start with. But it should be able to use those good features to start the process. Alright, so we got all this A data stuff. Let's kick it, make it happen. And hopefully this shouldn't have to train for as long before it starts to get somewhere. Come on, come on. Aesop, help me out here, man. Also, there's the very real problem that, like, Aesop's Fables translated by someone is probably, like, reasonable text that someone would recognize. However, Dr. Seuss is very unique. Very distinct. There's a lot of repetition that you wouldn't normally see. But I'll be curious if I had like a text generation model that worked in general. If you trained it for a little bit on Dr. Seuss, how well could you generate things like that look like Dr. Seuss? Or something like that. That would be interesting. Is this still not done? This is misery. I tell you, misery. Machine learning, the waiting is the worst part of this. Okay. So yes, now it's going to take like 2.5 minutes to plow through one of these because it's 1/5 of the data is 40,000 data points because it's all about 200,000. So yes, it will take about 6 times as long to go through everything. Well, hang on. It was 30,000, now it's 200,000. It was 6,000, now it's 40,000. Yeah, alright, it's about on track. 6 to 40,000, yeah. Okay. 6.5. Which if it was taking like 15, I thought it was like 11 seconds. 6.5. It seems slow. I guess it's got more data. It's paging through the data more slowly. Something like that. We are starting to get some accuracy here. You can see that climbing up. I want to sort of let it finish one epic, one set of the fables. In particular, I should junk the last, I don't know, 10% of the model, because that's not from the actual fables. That's just like historical stuff about Aesop, which is going to have a whole lot of like Greek name, Which, well, I mean, that's interesting if I wanted to generate some like history of Greece. That's not in general what I want the model to be able to do. More generally, we'd like to be able to train a little bit on some vaguely English text, so we get things that don't look like this. So I'm just going to let it do one single epic. Just one. Because that's more data than it got to look at for all of the Aesop's business. So we'll let it finish out this epic. It'll be fine. It'll probably reach like 30% some accuracy, whatever. It'll know what words are. If we really wanted to, we can make a super simplified language. That's just like word space, word space, word space. Question from the audience. What is the better way to put your code in a Git repository? IPython notebook or a Python file? If you're putting your code under version control, I highly recommend raw Python text files. GitHub can display Python notebooks, and I have one that does this somewhere. Let me see if I can find it. But it natively, like, it's storing text in the background. That's all it's doing. Oh, I do have a Bardic up here. Okay. But the problem with IPython notebooks is they're stored as, like, some strange JSON format. I mean, not that JSON format is super weird, but it's just not super nice to look at in text. So it'll show and it'll render like, oh yeah, this looks really good. But then, like, if you click on the raw, like, it looks like this. And you say, oh, this isn't that bad. I mean, that's formatted text. And then you have, like, an image somewhere. That's when it's terrible. Because to store that image, it stores it as base64, so it's all very ASCII-like, and it blows up the size of your file. And if you replot the image, even if your image only changes a little bit, the base64 encoding of, like, the JPEG or the PNG is probably going to change a whole bunch. So it's going to be this huge diff, and your repository size might grow quite large. So I would recommend not doing that. I have looked at doing notebooks in pure Markdown. It's like you can have Markdown cells in your notebooks, but storing the notebooks as Markdown. I had an extension for that for a while, but like it just wasn't natively supported, and it got to be a pain. But I think that would be great if notebooks could just be stored as Markdown, or even as restructured text. It's a very similar kind of syntax, but I think it was made for Python, or Python natively supported it, or the Python documentation supports it, or something like that. And now I've gone on long enough to where it's we might actually finish a second epic. 2 epics! Amazing, astounding, more than ever before. We'll be interrupting this very shortly, though. But yes, that's what I recommend. Store the raw Python files. Certainly use the notebooks, like while you're fooling around, while you're figuring out how something is working. You want to share it with a colleague. Put it up, I think there's GitHub gists. That would be perfect, I think. Store your gist. Store your IPython notebook as a gist. Definitely do that. And then you can share that with your colleague. You can say, hey, what's this thing that I have? So I think that would be the use case for what you're trying to get at there. I happen to have one in this repository because it doesn't change that very often. And it's convenient to display in a super nice format. I probably should have put it in a gist. Okay. There we go. We are interrupting this now. How did it actually do that? It got up to validation accuracy 37. That's actually not as bad as I might have thought, to be honest. So let's see how it does now. It got actually less training than the previous model, because the previous model got 5 epics through 30,000 data points. This got essentially 1 epic through about 80,000 data points. Yeah, so check that out. That looks like text. I mean, a lot of these things aren't quite words, and there's this string of new lines, perhaps because the base text has several spaces with new lines. That like, oh, you have two or 3 new lines. Yeah, that's just a feature of this text. So it has learned that kind of behavior. And it's getting there. There's a lot more to learn here. The quick brown fox jumps over the lazy sophist. And the killed bore elves that was boppled as the fell. Sore war afford into the... Alright, so there's not a whole lot of words. Not a whole lot of words as yet. But I want to do one last thing. Let's save the weights from that model. And make sure we have those on hand. And let's build an even bigger model now. And we're going to stash in the weights from the previous model. And I don't need this many blocks anymore. I guess we'll do 5 again. Because I don't want any trouble. And we can play the same game. We can see how this extra large model works. So we have a slightly more complex model now. Model 3. And we can see if it spits out anything but garbage. Again, we expect only garbage. Even if we're putting in good things at this layer that we've pre-trained, this layer is garbage at this point in time. But with just a little bit of training, it should start to look decent. Come on, big money, big money, big money. Gotta compile that model. Yes, so as you can see, mostly garbage. I think that's garbage. Let's just go one pass. And we're going to retrain this back on the Dr. Seuss dataset, because why not? See how long this takes. We, in theory, have already compiled the model, so we shouldn't need to do that again, but it might do it again anyway. I don't know if compiling for training versus compiling for fitting is a different process. It might be that if you compile for fitting, you get the compiling for training for free. Or sorry, if you compile for fitting, you get compiling for predicting for free. But maybe not the other way around. It seems like it will not be giving me what I desire. If you are interested in this project, you can go to my GitHub page, github.com/dvubuntu, and check out one of my repositories, Bardic. I'll be pushing an update after the stream today. And so it's got like a brief example of what the heck we're trying to do. And the file that you're looking at right now. Not as an IPython notebook. But I would consider trying to stream from my Python notebooks. I just have a good workflow where I don't need to do that. Is this really still? Really? Really? Come on. Do it. Do it. These models take a long, long time to compile. Yeah, it's just trying as hard as it can. I don't know why it's so... Let's see. There it goes. Okay, finally. That's a little better. Yeah, my GPU is running a little hot there. 55 degrees Celsius. Halfway to boiling, you know, it's fine. Everything's fine. We're all fine. So let's see how it does. We'll give it like one pass through all the data or something. It's like 30 seconds per chunk here. We got 5 chunks. We're going 2.5 minutes. That's not the end of the universe. But yes, so you can go here and you can play around with this data. This is not, like, it's a Python script, but I caution you that it's not something that you would just hit run and see what happens. That would be a dangerous thing to do. It'll probably take forever to finish, A, and B, it'll save all kinds of garbage to your directory. And if you want to get the Dr. Seuss text, you go to this fellow's GitHub page, Robert S. Diona. If you search Dr. Seuss text file, you'll probably find it. And similarly for ESOP. If you want to try your own text files, you can also do that. That's certainly recommended, an easy thing to do. Look at this, we're already at accuracy, validation accuracy, 31%. So what the question is, what were we at when we stopped training that model before? We were at... So originally with the Dr. Seuss data, our finishing validation accuracy was somewhere in the high 20s to high 30s. Yeah, somewhere around that area. Oh, jeez. I didn't realize that was that bad. 31, 30... But we're trying to train it on two different kinds of text at once. The fables and the Dr. Seuss. So it might be expected that, particularly like we trained up this first layer. Let me go fetch it. We trained up this first layer on Dr. Seuss, and then we trained up the first two layers on Aesop, but the first layer had more or less been, we thought, decent, although it was keyed on interesting Dr. Seuss things. And then now we're once again back to Seuss on the third layer. But really, it's affecting all the layers each time. Okay, so that's that. Let's see what it looks like then. Bang. Again, I'm always a little surprised this takes this long. So our final accuracy, ooh, well, yeah, probably a little lower. So I expect this to actually be worse at this point, which is unfortunate, indicating that perhaps this did not work as I intended. Yeah, and it looks about as bad. It probably just has the general structure right, as far as how many I's there are, how many E's there are, how many spaces there are. Like it knows that that's a word, that's a word. Those might be the only words in here. That's a word. Look, we got a goat bow. That sounds like a very Dr. Seuss thing to say. Okay, there was one other thing I wanted to try, where I take my previous net and I want to add nodes to one of the layers. And so you can't just copy the weights directly now, because now I've got a whole lot more weights on an earlier layer. So you need to be very careful about how you copy those weights. This is what I went into last time. So let's try to do this. So all we did is double the size of this first LSTM layer. That's all. Nothing too fancy. But to get that to model 4, not summary, get the numbers to work out right. There we go. So this has 128 blobs. Here it's got 64. But really, hang on. There we go. www.shape. There we go. Or www in www. A whole lot of these. One of these days I will type appropriately. There we go. That and 4. Doink. Okay. So it's got the same embedding layer. That can be transferred, no problem. This part thing's good. Kooky. So you've got this 256 in our old one. It's sort of the 64 times 4 things you get. Likewise here. Here, we got 512, because it's 128 times 4. I don't think it's just the first half we should fill up. But I believe I said it was the first quarter and the third quarter. Alright, so that's all we're doing here. What am I doing here? WW. Interesting. So I don't actually use WW4. I store it in here. Okay, that's fine. That is totally fine. So this is the first quarter of that layer. This is the third quarter. Then you have to do the first quarter and third quarter for the, oh gosh, what is this? The recurrent units, and then likewise for the bias terms, I think. And then you can actually set the weights. And then I'm still going to numblocks 10 this. There's no reason to change that, really. Yeah. No real reason to change that. Now this, before I train this, this might actually be, because I've just added weights, I'm sorry, I've just added some nodes. I still have nodes with information getting all the way to the bottom. It's getting corrupted a fair bit. by these extra 128 nodes, but that might not be crazy. Let's find out, shall we? Let's see if this model produces anything vaguely decent after stuffing in our trial values. That's all I want to see. And if it doesn't, that's not surprising again. It just would have been really, really curious. God, these compile times are killing me. Killing me. I might have to change my Theano settings to be fast compile instead. Murder, murder, come on. I'm going to go ahead and say these are not that decent. This is actually, I feel like this is qualitatively different from the samples we saw earlier, though. That were garbage. Like this. Maybe it's not. Maybe it's about the same. To me, this looks like the spacing is starting to get correct, but not there. And I don't think that's just the inherent property of the model. So now it will take forever to compile, and then we'll get onto it. And I guess just running these models with these data sets will be the last thing we get to. And then maybe I'll let it train for a good while longer on this larger data file. We'll see what happens. If I run it for 10 epochs or something, who knows? Maybe that'll be interesting. We can get some actual Seuss-like data next time. All right, so if there's any more questions from the audience, now would be a great time. As my computer grinds to a halt trying to keep up with this computation process and streaming. That's using my 5-year-old GPU. Oh my goodness. Is this seriously not done compiling? There it goes. Finally. Alright, so 40 seconds per iteration, or per pass through 1/5 of the data. So, 200 seconds. A little over 3 minutes. For the entire, to make one epic pass through the Dr. Seuss data in this environment. Okay, so I'm just glad that we have that model going. I don't know if this is really worth it. I should redo this process, rebuild this final model without any of the iterative building up style for the same amount of time that it got to train on all the models, perhaps, and then see if it's any better, or see how that compares. And you would want to do this 100 times or something to get a sense of, over random seeds, does it make a difference? I just thought it was a cool idea to start training a smaller model and then use that to bootstrap the bigger models and try this on some real data. If someone is familiar with this in the academic literature, I'd be really interested to hear about that. I specifically didn't do a search for this kind of thing because I wanted to see what I could come up with, and then maybe later go back and see, what has everyone else done? And now I have hopefully a slightly better understanding of how that process works. But that's all we got for this week. I believe we are still on for next week, and we'll see what kind of data we're going to do. I like the text generation problem. It's cool. It's fun. It doesn't stream well because this training process just takes a long time. So I might try to move into something else. If you have a particular topic you'd like me to see me stream, or a particular piece of software you'd like me to take a look at, send me an email, leave a comment, any of those things, and I will see what I can do. Alright, I think that's as much patience as I have for this. So, I want everyone else to stay cool, have a good night. Don't forget, stay safe in the data mines. Take care.